Good morning, Year 12. Just going to go through a question from exercise 3B, which was to do with arithmetic series. So the first question I'm going to go through is question 12, starting with part B. So your series 4p plus 8p plus 12p plus ... plus the final term to add up is 400. And the first thing you're going to do is work out an expression for the number of terms in this sequence, and the answer is going to be in terms of p. So in other words, they want you to focus on that final term effectively and find out what n would be for that final term. So I'm going to focus on this and call that un, and effectively n is the thing I want to work out. So un is 400, but for an arithmetic sequence, the formula would be a plus n minus 1d. And then you know from the series itself that a would be 4p. N is the thing you want to work out. D is the common difference. If you took the difference between consecutive terms, that would also be 4p. And that's equal to 400. And now you've got to make n the subject. So there's many ways to do this. You could, for example, subtract 4p. Could expand the brackets. Most people would expand the brackets, but I'm not going to. Then you could divide by 4p, and then you could add 1. And if you actually simplified this, wrote this as a fraction as well, it would be 4p over 4p. And the 4p's on the top would cancel out, and you'd be left with 400 over 4p, which is the same as 100 over p. And that would be it for that one. Now part 2 is show that the sum is equal to 200 plus 20,000 over p. It's an arithmetic sequence. If you remember, the arithmetic series, has two different sums. It's either this one, which is the one which is used 90% of the time, or it is this one. And the difference between these two is this one includes the last term. We don't really ever know the last term, but they've given us the last term in this series. So I think I'm going to use the second one. Both should work. So Sn is equal to n over 2 now. I'll put n over 2 in there like that, but a is 4p, and the last term is 400. And the first thing I would do is get rid of the half on the outside by dividing each of these terms by 2. So that's 2p plus 200. And remember now, n is the thing you worked out in part 1. So you can substitute that into this, and you can get 100 over p, brackets 2p plus 200. If you expand the brackets, you'd get 200, p over p disappears, and 20,000 over p as required. So it was a show that, so that matches up with the show that. You could have got it from the other sum, but the algebra probably would have been a lot more complicated. Part B part C is a different series, or different sequence actually. 3p plus 2, 5p plus 3, 7p plus 4, and it's asking for the 80th term, so it's asking for U80, which again, always quote the formula, a plus n minus 1d. The first term in this sequence is 3p plus 2. The term you want to find out is 80, so it's 80 take away 1. And the common difference would be the difference between consecutive terms, which looks like it would be 2p plus 1. And then technically, oh no, they say giving your answer in its simplest form, so I do have to simplify. So if I expanded the brackets, what would I get? I would get 158p plus 79, which is equal to 161p plus 81. I think that is pretty much it.